Venn diagrams are very useful in visualizing the relationship between sets. In Venn diagram, any set is depicted by a closed, which is normally this. So for example, we could have a Venn diagram, which is this, whereby the universal set, the rectangle represents the universal set, and we have a region which is a scoop. We have a region which is a circular part, which could also represent another set, which could be set A. We also have a set. In this case, we represent it at, and how do we represent it on a Venn diagram? We would have our Venn diagram, and we have our two sets, which is A and B, where A is a subset B. In that case, we have it to be this. Our first one, A being a subset of B, have our B out, then this becomes our A. We are going to take set operations and then set operation, and then learn how we can represent them on a Venn diagram. So first, let's take union. The union of two sets is set containing all elements that are in A or B. The line word is or possibly both. For example, we have a set which could be 1 and 2, and we are trying to find the union of that set with another set which is 1, 2, and 3. So in that case, the union of this set will be 1, 2, and 3. We can write X belonging to a set which is A union B if and only if X belongs to A or X belongs to B. Note that A union B is equal to B A. So let's see how we can use the Venn diagram to represent the union of a set. So with a Venn diagram, we're drawing in the union of a set. We have that, we'll get this. We're using the Venn diagram to represent it. We have this. And then we have our X, which represent the universal set. And we have this. This is set B and this is set A. So for A union B on the Venn diagram, it's going to be the whole portion of this. In this case, this represents the A. Note that similarly, we can write the union of 3 or more sets in a particular. Let's note if A1, A2, A3 to AN are in n sets, their union, which is A1 union A2 union A3 union AN, is a set containing all elements that are in at least one of the set. So in this case, we could write that the union of the set I equal to 1 and AI. So let's take example from this expression. So with example, if A1 is equal to A, B, and C, and A2 is equal to C, H, and A3 is equal to AD. Then we could write that our UI AI equal to A1 union A2 union A3, which is equal to A, B, C, D, and H. I hope you had that. Let's move on to the intersection. The intersection. The intersection of two sets A and B is denoted by A intersection. So this notation represents intersection consisting of all elements that are in A and B. Let's take note of this, and B. For example, we would have that 1, 2, finding the intersection with 1, 3. So therefore, our intersection is 1. So then let's use the Venn diagram to represent the intersection of A and B. And in this case, we're going to use the shaded one to represent the intersection. So for the intersection of A and B, we have our Venn diagram drawn. This is our inverser set. We have this. We have our A. So for A intersection B, this shaded region represents A intersection B. More generally, for set A1, A2, A3, A, N, their intersection will be this intersection I, A, I. Is defined as the set consisting of the element that are in A, I's. So in this case, for 3 sets, so this is our A, B, and C. For that, intersection will be here, shaded part. So for the shaded part, shows the set of what? A intersection B, section C, which is. Now let's move on to the complement. Complement. The complement of set A is denoted by A to C at the top or A bar. Is a set of all elements that are in the universal set S but are not found in A. So let's use the Venn diagram to represent that. We're using a Venn diagram to represent that. We have this, and this is our A, and this is our S. So for the complement section, having that, this section represents the. Let's talk about subtraction or the difference. The difference is defined as follows. The set A minus B consists of elements that are in A but not in B. For example, we have our A should be equal to 1, 2, 3. And then our B, set B is 3, 5. Then our A minus B will be equal to 1 and 2. So for us to represent that on a Venn diagram, you know that our Venn diagram for the difference will be this. Have our set A, our set A. So for A minus B, shaded one will be this, which can be A only. Let's move on. So we have something called mutually exclusive. Two sets A and B are mutually exclusive or disjoint if they do not have any shared element. Their intersection is empty. So if we have a set which their intersection A and B is empty, then we could term it as a disjoint or mutually exclusive. And for that, when we are representing it on the Venn diagram, you know that we have this. For three sets, we have 1, 2, and 3. So this could be A, B, C. And for these sets, they are mutually exclusive.